Hi everyone, I welcome you to my channel, and today we are going to discuss the concept continuity. And we know that this is a very important concept, and this concept, that is continuity, will be essentially in the continuation of the concept limits that we have done in our previous videos. And today we are going to learn some basic concept on continuity. Let's start with first example, that fx is equal to 2 for f if x less than equal to 0 and equal to 3 if x is greater than 0. Okay, let's see that where this function is defined. We know that this function is defined for all real numbers. Now we are trying to find, first we will try to find the limits, that is left hand limit and the right hand limit of the function at x equal to 0. Let us calculate this. Okay, left hand limit at x equal to 0. First we calculate left hand limit. We know how to calculate limits. Limit x tends to 0 minus fx, right? Then limit x tends to 0 minus, that means x is approaches 0 from the left hand side. Then when x is approaches to 0 from the left hand side means x is less than 0, so fx can be replaced by 2 and this is equal to 2. So we got the left hand limit as 2, and let's calculate the right hand limit. Right hand limit x tends to 0 plus fx. So x tends to 0 plus means that you are approaching 0 from the right hand side. That means here the value of x will be greater than 0. So fx can be replaced by, okay, this is right, this fx can be replaced by 3. So this is equal to 3. So what we have seen, the left hand limit is equal to 2 and the right hand limit is equal to 3. So left hand limit and right hand limit are equal for this case. We are trying to find the continuity at 0. So let us represent this with the help of a diagram. Okay, and we have seen that you want to draw the diagram, you want to draw the graph. Okay, so this is a line that gives us y is equal to 2, and this is a line y is equal to 3. Okay, now in case you want to draw the graph, we know that if we approach 0 from this left hand side, then we can just move up to this point. Then to continue the graph, we have to lift the pen from the plane of the paper. So that means this graph we are not able to draw, okay, in one stroke. We have to lift our hand, we need to draw. So therefore, when we approach to 0 from the left hand side, right? Okay, at 0 there will be a break. That means this is an example of discontinuous function. So this is discontinuous at x equal to 0. Okay, so let us try to take one more example. Okay, this is another example, that is fx is equal to half for x not equal to 0. Then fx equal to 1, x equal to 0. Okay, now what I'm going to do, like the previous example, we're trying to take find the limits at x equal to 0. Let's see that. Okay, at x equal to 0, we'll first calculate left hand limit. Okay, left hand limit. We know how to calculate. X tends to 0 minus fx. X tends to 0 minus fx, and limit x tends to 0 minus fx. So x is approaches to 0 minus means x not equal to 0 case, then fx to be replaced by half. So you got this is equal to half. And similarly, you can calculate the right hand limit, right? For the right hand limit also, right hand limit, you know how to calculate this, but still I need to calculate this. I need to show you so that we can stress on the point then whether this function will be continuous, and in case the function is not continuous, at what point the function is not continuous. Limit x approaches to 0 plus fx. Okay, limit x tends to 0 plus. Right here also x is approaches to 0 from the right hand side, so therefore x is not equal to 0 case. X is not equal to 0. This is also half. Okay, this is also half. So what we have seen here left hand limit and right hand limit, both are same. But let us see what is the value of the function at x equal to 0. So what is the value of the function? So if you just write the value of the function as 0, if you take the value of the function as 0, that means f of 0, okay, functional value at x equal to 0 is equal to 1. So finally, we can just say that left hand limit and right hand limit, right? Left hand limit, right hand limit, both are equal to half, right? Both are equal to half, but the functional value at x equal to 0 is equal to 1. So you can just write finally that left hand limit equal to right hand limit, but it's not equal to functional value at x equal to 0. Okay, let's see the graph. You can try to understand the graph. Okay. So if you keep on drawing this graph, right, we have seen that when you be approaching to 0, okay, there will be a break. Then again you can continue the graph, but there will be a break at x equal to 0. So in case you want to draw the graph, can you draw the graph in one stroke? So if you keep on drawing the graph, then you will have to leave the pen. Again you need to draw this. So therefore, this is also an example of discontinuity at x equal to 0. So this is also an example of a discontinuous function at x equal to 0. Okay, let us move to the formal definition of continuity. Then on what conditions we can say a function will be continuous. Okay, let f be a real function. Okay, defined on a subset of real numbers, and let c be a point in the domain of f. Then the function f is continuous at c. So we are discussing today that continuity at a particular point. Remember this. Okay, we are just focusing on continuity at a point. Okay, f is continuous at c if limit x approaches to c, fx is equal to f of c. So what is the meaning of this? This is a very important definition for continuity. What is the meaning of this? That means when you be approaches to c, okay, so when you will be writing x approaches to c without any sign, then you will understand that you are approaching c from either of the sides. That you are approaching c from the left hand side, you are approaching c from the right hand side. So you can just expand the steps like that. That limit x approaches to c minus f of x, and limit, because since we are not writing any sign, okay, so we are not denoting the c with a help of any sign. So you can just, that means both the signs are included there. So you can just expand this limit x approaches to c minus fx, limit x tends to c plus f of x equal to f of c. So what is this? According to the definition, what is this? This is limit x approaches to c minus fx. That means this is the left hand limit. Limit x approaches to c plus fx. What is this? This is the right hand limit, and this is the value of the function at c. Right? So if a function is to be continuous, then left hand limit at a particular point should be equal to right hand limit and should be equal to the functional value. In that case, we can say the function will be continuous at that point. So we can just move to important questions. Let's discuss the continuity of this function fx is equal to mod x at x equal to 0. Already I said that these are the very basic questions. Okay, and you please try to solve always from the easy to the difficult questions. Okay, now let us solve these questions. So what we can do is, first initially we'll write this function in a simple form. Okay? Then mod x, we know that what is the definition of mod x? It will be x if x is greater than or equal to 0, and this will be minus x if x is less than 0. This is the definition of mod x. So the question is, discuss the continuity of fx equal to mod x at x equal to 0. It's specifying that you need to discuss continuity at x equal to 0. So just try to first find out the left hand limit and right hand limit. So first left hand limit, right? Left hand limit, limit x tends to 0 minus fx, right? Limit x tends to 0 minus. So what's the meaning of this? X is approaches to 0 from the left side, that means this x is negative. So x is negative, therefore fx to be replaced by minus x. And in case if you substitute this limit, if you put the value of the limit, it will be 0. Though it's minus x, but x is approaches to 0, so the value of the limit is 0. Now we'll calculate the right hand limit. Okay, what is the right hand limit? Limit x tends to 0 plus fx. Limit x tends to 0 plus. 0 plus means you are approaching 0 from positive side, so axis, sign of x is positive. So that means x is greater than or equal to 0. So you need to replace fx by x. So there, in this case also, if you substitute 0, it will be 0. Like we got left hand limit and right hand limit, both are equal. Now what is left out? It's left out with one step. What is the value of the function at x equal to 0? Have you seen this? Fx value is equal to x. Then when x will be equal to 0. Okay, so therefore you can just write f of 0. You can just replace the functions, this x by 0. So if you replace this x by 0, the value of this is fx equal to x, so f0 will be equal to 0. So what we have seen that left hand limit and right hand limit both are equal, and both the values are equal to f0 equal to 0. So left hand limit, right hand limit, and the functional value. That is, you can just write left hand limit and right hand limit, and the value of the function at 0. It's same, equal. Therefore, based on that definition that we have learned just now, we can say this function, that fx equal to mod x, is a continuous function. That means it is continuous at x equal to 0. Though we know that this function, of course, continuous everywhere. Okay, so in case if we just want to represent this one, okay, with the help of the graph, we know the graph of fx equal to mod x. Okay, and if I just draw the graph of fx equal to mod x, we know that this is a V-shaped graph, right? This is a V-shaped graph. So if you want to draw the graph, you can just keep on drawing the graph without lifting the pen from the plane of the paper. Okay, therefore this is an example of continuous functions. Okay, let us move to the next concept. Okay, discuss the continuity of the function fx equal to 1 by x for x not equal to 0. It's specifying what is the domain of these functions, all real number except x equal to 0. So it's a reciprocal function. It's a very important function. First, try to find, okay, discuss the continuity. So it's not specifying that you discuss the continuity at a particular point. What we'll be doing is, we'll take an arbitrary point, okay? So just we'll solve this one. Let C be any non-zero. Let C be any non-zero real number. Okay, C be any non-zero real number. So let's try to find the continuity at x equal to c. So limit x tends to c, f of x. Limit x tends to c. So fx you can replace by 1 by x. Okay, then this is equal to 1 by c. Right? So we have seen that x approaches c means we are here when x will be approaches to c from either of the directions. So both left hand limit and right hand limit are included there. So limit x approaches to c fx is equal to limit x approaches to c, fx can be replaced by fx equal to 1 by x equal to 1 by c. Why? Because okay, then fx is equal to 1 by c. And apart from that also, we can just write what is the functional value. Can you substitute c value? Yes, we can substitute because c is a non-zero number, right? If we just substitute f of c, then it is equal to 1 by c. So what we can write from these steps, we can write that limit x approaches to c f of x, right, is equal to 1 by c, that is equal to functional value. So this includes both the left hand limit and the right hand limit. So left hand limit and right hand limit both are equal and is equal to 1 by c, and that is equal to the functional value at c, that is f of c. So therefore this function for c any non-zero real number, this function is a continuous function. Okay, let's okay, now we just move to the last question of this lecture, that is fx. Again we have taken the same reciprocal functions, but we'll try to see the limit of this particular functions. So basically to discuss this one only, the previous example we discussed. Okay, let us see what will be the limit of this function, that is f(x) equal to 1 by x when x approaches to the 0. Okay, so first of all try to understand this table. Okay, this f(x) equal to 1 by x. So what we have done is that slowly we are trying to minimize the value of x. Like x equal to 1, it's 1, 0.1. If you substitute x equal to 0.1 is equal to 10. If you substitute 0.01, it's equal to 10 squared. That is 0.001 is 10 cubed. So it's 3 decimal places are there. So it will be 3. That is 10 3. Okay. So and similarly other values you easily can understand all this. We'll just continue. Only our focus is that the moment you gradually what are you doing? Gradually you are reducing. That means minimizing the number. Slowly you are coming closer to 0. Okay, from the right side. The moment you move from this to this, slowly the values are decreasing. That means you are slowly decreasing the value of x. But the other way, have you seen the value of fx? The fx value is started increasing. Okay, the shooting up. Like the values are slowly, gradually increasing. Right? So you are decreasing the numbers. These values are increasing. If it is 10 to the power minus n. 10 to the power minus n, it's plus 10 to the power n. Okay, it will keep going like that. The meaning is that if you approach this to 0, this is 0. If you approach this to 0, the value of this, just as the graph of the functions, keeps on moving up and up. Okay, therefore this one we can just represent with the help of the limit. So how to write this? So limit x approaches to 0 plus. That means when will be approaching to 0. Okay, when will be approaching to 0 from the right hand side. Okay, then this fx value, right? This is limit x tends to 0 plus fx can be replaced by x. So that value will be very large. That means you can just understand this one, that this particular value can be made larger than any number that you think, right? Any number you can imagine, the number can be made even larger than that number. So therefore that can be written as a plus infinity. So with the help of that we can just understand the plus infinity in terms of the limits. Okay, now similarly we can explain that limit x tends to 0 minus. That means when we be approaching to 0 from this side, from the negative side. Okay, we can just understand. We can just understand with the help of another table that when we be approaching to 0 from the negative side, right? Then let's see what happened. Then if you approaching to 0 from the negative side, the value of the functions keeps decreasing and decreasing. Okay, therefore we can just understand in this way. Okay, that in this regard, that when we be approaching 0 from this side, the value of the function will be very small. That means the value can be thought of a very large negative number, which can be made even more smaller than any negative number you think, right? So therefore, limit x tends to 0 minus fx can be written as limit x tends to 0 minus, okay, fx, right? Fx is equal to 1 by x. So that can be written as minus infinity. So we have seen here that both the right hand limit and the left hand limit, when x will be approaches to 0, that means you can say that x equal to 0, both left hand limit and right hand limit does not exist. Okay, so with the help of this, we can just understand the concept of the plus infinity and minus infinity. Okay, these are the concepts that we have discussed in lecture 1, and the more concept that based on this will continue with the help of other concept in lecture 2. And thank you so much for watching my video, and if you like this video, please share this video, and if you have not subscribed my channel, and please do subscribe so that you keep getting the other videos, and I'll be trying to upload all the videos on now. During these days, we will just try to upload the videos on continuity, right? First, we'll try to complete the basic questions, then we'll move to difficult questions, and thereafter we'll be including questions will be very important for your other exams. Okay, thank you so much.